Boltzmann law. We know radiation is the phenomenon in which energy is transmitted or transferred by electromagnetic waves, which we generally call radiant energy. And we know all bodies emit radiant energy at all temperature, whether they are solid, liquid, or gas. Energy can be transferred by radiation over large distances without a medium. That is, heat energy can be transferred without a medium or in vacuum. The total electromagnetic energy radiated by body at absolute temperature T is proportional to the size of the body, that is the area of the body. This is from experiment. From experiment, we know that the total electromagnetic energy radiated by a body at absolute temperature T is proportional to its size or area. It is also proportional to the ability to radiate. And the ability of a body to radiate, we generally represent it by emissivity, which is represented by the symbol E. The radiant energy also proportional to the temperature, most importantly to its temperature. This was we confirmed from Stephen's experiment. And for a body which is perfect radiator, the energy emitted per unit time, if we consider that H, then H is proportional to the area or the size of the body. H is proportional to T to the power 4. So, if you take a perfect radiator, and for perfect radiator we take the emissivity E equal to 1. So, H will be equal to, that is the energy emitted per unit time H, that will be equal to A sigma E to the power 4. And as I have told you, here A is the area of the body and T is the absolute temperature of the body. And this is a very well known equation, and this relation or equation was obtained experimentally by Stephen and later proved theoretically by Boltzmann. That is why this expression is called, or this equation is called Stephen-Boltzmann law. And the constant sigma, here we have taken the constant sigma, it is called the Stephens-Boltzmann constant, or simply the Stephens constant. And this Stephens constant we can be verified. We can find out the value of this Stephens constant sigma by various methods, but in the next video I will show you how you verify the Stephens law by using electrical method, or by using electrical method how you can find out the value of this Stephens constant. And the value of this Stephens constant in SI, this value will be equal to 5.67 into 10 to the power minus 8 watt meter to the power minus 2 Kelvin to the power minus 4. And for lamp black, we take the value of the Stephens constant is very close to 1, or you may take 1. And for most of the bodies, they emit radiation which is equal to a fraction of the radiant energy. That is why we take another value which is called, or which we have previously defined, the emissivity. So in this equation 1, if you introduce this value or emissivity, then this equation 1 will be equal to H, that is equal to AE sigma T to the power 4. And in experiment or in our day-to-day life, we generally use tungsten lamp. So if you have a tungsten lamp of radiant energy 60 watt, then these are the standard configuration of the tungsten lamp. So for a tungsten lamp whose emissivity is equal to approximately equal to 0.4, and the area approximately equal to 0.3 centimeter square, temperature is equal to 3000 Kelvin, So if you put these values, that is 0 for area, you put 0.3 centimeter square, so this meter square, then emissivity equal to 0.4, so you put 0.4, this is the value of the Stefan's constant, and this is the absolute temperature to the power 4. So if you multiply or solve these values mathematically, then the value of H, that is the radiant energy H, will be equal to 60 watt. If you have a body at temperature T, and suppose the temperature of the surrounding is equal to Ts, suppose the body emits radiant energy as well as receive radiant energy. If the temperature of the surrounding is more than the temperature of the body, then it will receive, and if the temperature of the surrounding is less than the temperature of the body, then it will emit. Then for a perfect radiator, where the value of the emissivity is equal to 1, that is E value equal to 1. So for a perfect radiator, the net loss of radiant energy H will be equal to sigma A T to the power 4 minus Ts to the power 4. We just subtract it. And for a body with emissivity E, then the net loss of radiant energy will be equal to H, that is equal to E sigma A T to the power 4 minus Ts to the power 4. So using these two equations, you can estimate the amount of radiant energy or heat energy radiated by any body. Now let us estimate the heat energy radiated by our body. These are the approximate value. Suppose the surface area of the person's body is approximately equal to 1.9 meter square. Suppose the room temperature is equal to 22 degree centigrade, that is 295 Kelvin. So this is the temperature of the surrounding. Then what is the temperature of our body? Internal temperature, body temperature is, we know it is 37 degree centigrade, and the skin temperature is equal to 28 degree centigrade. Because the skin will radiate the heat, so you take the skin temperature, and which will be equal to 301 Kelvin. And if you take the emissivity of skin, suppose equal to 0.97, then what will be the rate of loss of heat? The rate of loss of heat will be equal to, if you put this formula, E sigma A T to the power 4 minus Ts to the power 4, where E, that is the emissivity, is equal to 0.97, and this is the value of the Stefan's constant, and this is the value of the surface area of the body, and this is the temperature of the 301 degree Kelvin. This is the temperature of the skin, and this is the temperature of the surrounding. So if you calculate, then the rate of loss of heat will be equal to, by our body, it will be equal to 66.4 watt. And this is the amount of heat lost by our body per unit time. So if it will be per unit time, means per hour, and suppose our body produce heat per hour 120 watt, then you see the amount of heat lost by the body, it is equal to 66.4 watt. So which is more than half the rate of energy production by the body at rest. So most of the heat energy by our body is emitted, is radiated in terms of heat. There are also other forms of energy loss by our body, but most of the heat is radiated from our body in terms of heat. So in this video we discuss about the theory of Stephen Boltzmann law. In the next video I will show you how to verify Stephen's law using electrical method. Thank you.